focus today is going to be chapter 6, lesson 5, which is going to be continuing to work with more two-step equations. One of the things that I'm going to be doing in this lesson is actually kind of pull away from the examples that are in your lesson here in your book, and we're going to be taking a look at some practice problems that are going to be on a worksheet. And so what you might want to do is to just kind of go ahead and have an extra piece of paper in your binders. You can open up to your homework check section and take out a piece of paper, and you can kind of follow along with me as I go through some of these examples here in a second. The first thing that I want to talk about here is when we're looking at solving two-step equations. Number one, the first thing that we want to remember is we want to look at whatever is being added or subtracted to the variable. That is what we need to work with first. So again, for example, if I have a situation, in this case, let's take practice one of let's say I have 5w plus 2 equals 22. Okay, again, we're going to be looking at what is being added or subtracted with our variable. In this case, we have plus 2, where we're adding 2, which means we would subtract 2 on both sides. 2's cancel out, so 5w would equal 20. And then from there, I would be dividing by 5. So w would equal 4. So that's just kind of a quick review of the two-step equations that we've worked with so far up until now. What we're going to be looking at today are situations where we're going to have to start incorporating or using the distributive property. For example, when you take a look up here, they're giving you 2 times in parentheses w plus 36. We have worked with that before. Earlier in chapter 5, we had worked with the distributive property. So one of the things that we're going to be thinking about as we solve these is, number one, we can go ahead and distribute that in, or number two, we can take a look at the number that's on the outside that's being multiplied by the expression on the inside, and we'll take a look at some of those here in a second. Okay, examples in your book that you can go ahead and look at would be example 1 and then also example 2. But like I had mentioned before, I'm going to go ahead and take a look at this practice worksheet here. We're going to take a look at some of these practice ones on here. I do believe that the more you can see of these types of problems, the easier it will be for you to solve them. So I'm going to go ahead and zoom in here a little bit more just to make them bigger, so you're able to see them on the video. Okay, so we're going to start off with number 1. You can see over here we have 3 times in parentheses x plus 5 equals 39. One of the things that I had mentioned before is we could use the distributive property. Okay, so I'm going to show you that method first. So if I'm thinking about the distributive property, remember I'm taking this outside number times each term on the inside. So when I rewrite this, technically 3 times x would be 3x plus 3 times 5 would be 15, and that would give me 39. So there's a basic two-step equation that we've worked with before. So then from here, I'm going to subtract 15 on both sides. So 3x would equal 24. Divide both sides by 3. Therefore, x should equal 8. Now I can check it. 8 plus 5 would be 13. 13 times 3 is 39. So using the distributive property is one way that we can go ahead and use to solve this type of multi-step equation. However, there's another way that we can do it as well. I'm going to start by rewriting the problem that we had. So 3 times in parentheses x plus 5 equals 39. Now, rather than using the distributive property, what you can do is you can take a look at this number that's on the outside. Okay, so we've got 3, 3 would be the term that's being multiplied by each term on the inside. Instead of actually using your distributive property and multiplying, what we can do is we can think, okay, well 3 is being multiplied by that. So the inverse of multiplying is division. Okay, so instead I'm going to go ahead and divide both sides by 3. Okay, 3 divided by 3 becomes 1, so that actually cancels out. Now what's left up here, I have x plus 5 equals, and 39 divided by 3 would be 13. Then from here I have a simple one-step equation. I'm going to go ahead and subtract 5 on both sides, so x should equal 8. And that's what we had come up with before. I do believe that most of the time when you're working with these, most of you are probably going to want to use this method to solve these because it ends up being easier. Okay, I think there's a lesser chance of making a mistake when you go ahead and divide by that right away and get rid of that number versus trying to use a distributive property. Okay, however, using the distributive property is another method. Not to say that you can't, but we might find that method 2 is going to be the easier way. If I take a look at example 2, we had 7 times x plus 8 equals 49. Again, find your variable. So I've got x plus 8 in parentheses, it's being multiplied by 7. I want to get rid of that 7 right away, so I'm going to divide both sides by 7. Okay, 7 divided by 7 is 1, so that cancels. What's left? I have x plus 8, and that's going to equal 7, because 49 divided by 7 is 7. Now I can go ahead and I can subtract 8 on both sides. So x is going to equal, and that should be a negative 1. Now some of us might say, oh, well that's a negative, is that going to be right? Well, let's go back and check, because they want us to check our solution. If I take negative 1 plus 8, that's technically 7, and then 7 times 7 would give me 49. So it does check, and it does work. Okay? We're going to take a look at another example here. Okay, let's try this one. Okay, because we have a negative here, so I'm going to rewrite it so you can see it better. So I've got negative 5 times x minus 6 equals 15. Okay? Again, here's my expression in here, and that's being multiplied by negative 5. So I want to get rid of the negative 5, so I'm going to divide both sides by negative 5. Negative 5 divided by negative 5 becomes 1, so that cancels. X minus 6 is left, and that's going to give me negative 3. Now, I was subtracting 6 here, so the opposite of subtracting is to add 6. So those are going to cancel. X should equal 3. I'm going to check. 3 minus 6 would give me negative 3. So I've got negative 3 times negative 5. A negative times a negative is a positive, and 5 times 3 is 15. So it does check. And again, I'm going to circle my answers just so they're obvious to see when you're working through them. Let's go ahead and take a look at question number 4. Try that one here. So I've got 10 times x minus 5 equals negative 80. Again, I'm looking at where my variable is. I've got x minus 5 is the expression inside. That's being multiplied by 10. So I'm going to go ahead and divide both sides by 10. 10 divided by 10 is 1. So I have x minus 5 left. Negative 80 divided by 10 would be a negative 8. Okay, and then looking at, I've got x minus 5. The opposite of subtracting 5 would be to add 5. So I'm going to add 5 to both sides. Those cancel. X is going to equal negative 8 plus 5 would be negative 3. So let's plug that in to see if it's going to work. Negative 3 minus 5. That would be the same as adding a negative, so that's negative 8 times 10. And that gives me negative 80, so it does work. Okay? What I would like you to do at this time is to go back and take a look in your book. We're going to go back to the bottom of your book on page 482, and I would like you to take a minute and go ahead and pause the video and go ahead and try to complete Got It problems A, B, and C. When you're finished, then turn your video back on and we'll check to see if you did those right. All right, hopefully you've had a chance to go ahead and complete those Got It problems A, B, and C on the bottom of 482. So let's take a look to see if you agree with my answers. Taking a look at letter A, I divided both sides by 2 right away. So I have x plus 4 equals 20, subtracted 4 on both sides, so x equals 6. I went ahead and plugged it back in, and it does work. Taking a look at letter B, I went ahead and divided both sides by 3, so b minus 6 equals 4. I'm going to add 6 to both sides. Therefore, b is going to be equal to 10. As I plug it back in, 10 minus 6 is 4. 3 times 4 is 12, so it does work. Taking a look at letter C, I'm dividing both sides by -7. So I have 6 plus D left equals -7. Subtracting 6 on both sides, D is going to equal -13. And again, I plugged it in and it does work. Hopefully you were able to come up with the same answers. Let's go ahead and take a look at the next page, 483. Okay, so on 483, what we're working with here is when we have rational coefficients. Now remember, rational means that a number can be written as a fraction. So we may be looking at situations where we have fractional coefficients or fractions that are on the outside. Sometimes it could also be a decimal, so just kind of be aware of that too. Example 3 gives you a situation where you have a fraction on the outside. Example 4 is a decimal. All right, so what I want to do is I'm going to back up to our practice worksheet. And I'm going to find some here where we have fractions, okay? As I take a look at number 8, they're giving us 9/10 times x plus 8 in parentheses, and that's going to equal 18. Now the thing we have to remember when we have a fractional coefficient is normally we would divide, but because it's a fraction, we're going to multiply by the reciprocal. So I'm going to multiply by the reciprocal of 9/10, which is 10/9, and I need to do that on both sides. Okay, so those are going to cancel. X plus 8 is left. Equals, I can cross reduce. 2 times 10 would be 20. Now I can go ahead and subtract 8 on both sides. So x should equal 12. Now I'm going to double check it. 12 plus 8 is 20. And if I take 9/10 times 20, 9 times 2 is 18. And so it does work out. Let's go ahead and take a look at number 10. Again, we have another situation where we have a fraction as our coefficient on the outside. So I'm going to go ahead and rewrite that problem. I have 3/7 times x minus 2 equals 15. So because I have a fraction, I'm going to multiply both sides by the reciprocal. So those are going to cancel. 7/3 over here. I can cross reduce. Divide both 15 and 3 by 3. 3 becomes a 1, 15 will become a 5. So x minus 2 is going to equal 5 times 7, which is 35. Add 2 to both sides. So x should equal 37. Now I can go back and double check this. If I have 37 minus 2, that's 35. And I'm going to multiply that by 3/7. 3 times 5 is 15, and so that does work. Okay, so those are 2 examples of fractions as coefficients. Let's take a look at a decimal coefficient. So we're going to take a look at practice problem number 12 here. You can see we're taking 4 5/10 times x minus 9 equals -13 and 5/10. Again, I'm going to go ahead and rewrite this. So I've got 4 5/10 times x minus 9 equals -13 and 5/10. I'm going to go ahead, I can divide decimals. So I'm going to divide both sides by 4.5. Those are going to cancel. X minus 9 equals, and we would have to divide that out. Okay, I don't have my calculator with me, so you can go ahead and divide that out. And then I'm going to add 9 to both sides. Okay, and then x would equal, and we would have our answer there. Let me grab my calculator quick while you can calculate it. So I came up with -3 here, and then -3 plus 9 would give me +6. Okay, and I should be able to check it. So if I take 6 minus 9, that'd be -3, and then -3 times 4.5 does give me a -13.5. So there's an example with a decimal coefficient. 14 is the same way. So we can go ahead and divide both sides by 4/10. So those are going to cancel. I'd have x plus 2 and 4/10 would equal 2 and 96/100 divided by 4/10 gives me 7.4. Subtract 2.4 on both sides. So x should equal the whole number 5. Okay? And if I plug it in, 5 plus 2.4 would be 7.4. And then we're going to take 7.4 times 4/10, and I come up with 2 and 96/100. So those are just a couple extra examples that you could see and follow along. What I would like you to do right now then is to go ahead and take a look back in your book on the bottom of page 483, and you can pause the video and go ahead and do letters D, E, and F. All right, now that you've had time to go ahead and work on problems D, E, and F, hopefully you're going to come up with the same answer I did. So letter D, we should have D equals negative 57. Again, you're going to multiply both sides by the reciprocal, which would be 4, and then add 3 to both sides. Letter E, we should have come up with D equaling 10. Divide both sides by 75 hundredths, and then subtract 6. Letter F, we should come up with T equaling 69. So multiply both sides by 9/5 and then subtract 3. Okay? What I would like you to do right now is you can go ahead and take a look at the website and begin looking at the extra practice problems that I would like you to work on.